Hi everyone! In this video I'll show you two methods how to calculate torque that you can use to solve all the problems in this unit and in this WebAssign. So look at this example problem from the WebAssign torque. It's about the fisherman and the fishing pole, and there is a force applied by the fish. So the axis of rotation is where the fisherman is holding the fishing rod, so the force is applied that way, and the lever arm is given. You can reference this problem in your WebAssign. Let's look at method 1. You first create a sketch of the problem, and you define the axis of rotation, which is at this point. Then you draw the lever arm from the axis of rotation to the point of the applied force. Then you have to put these two vectors, the lever arm and the force tail to tail, and to start counting the angle of rotation from the lever arm to the force. That will give you the direction of the rotation. And by definition, if it's clockwise, then it's negative. If counterclockwise, it's positive. And that is how you solve the. So then you have to write the definition of the torque, which is the lever arm times the force times the sine in between those two. In this case, the angle between the lever arm and the force is 20 degrees plus 37 degrees, which is 57 degrees. And you calculate the numerical value, which is 209.7 Newton meters. The sign is negative. The rotation is clockwise. That is the first method. That's the method that I prefer, and I prefer to use most of the times. However, there is a second method you can use. And the second method involves splitting force into two components, parallel and perpendicular to the lever arm. So in this case, when you have the vector of the force, you can it's a freehand, sorry. So this is the parallel component, right? It's also shown right here, which is F times cosine 57, and this one is a perpendicular component right here, which is also shown here, which is F times sine 57 degrees. And so the parallel component creates no torque, because now you can see that the angle between the parallel component and the lever arm is 0 degrees, and the sine of 0 degrees is 0. So there is no torque created by the parallel component. And the perpendicular component is the only one that creates torque. Therefore, to find the torque, you just have to multiply the lever arm times the perpendicular component, which is whatever values you have in your WebAssign, and it will be the same number, 209.7 Newton meters. The direction is negative, which is clockwise. Use either method you like, and please fill out the Google form. Thank you.